We're taking a regular 60% Vortex Pok3r wired mechanical keyboard, and we're going to be changing just about every single aspect of it, including making it wireless. This was more of an experiment to see if I could even pull it off, and it ended up being a massive amount of work, so let's go. I decided I would try and make it even harder on myself by stuffing the largest battery that I could fit inside of this case, so big that it actually didn't fit, which is why I'm taking a Dremel to the case right now. And we are off to a great start. I figured I could get away with just taking off those two back supports and then also that ridge down the middle of the case. Now I'm taking my time and I'm going very slowly because the case isn't actually that thick. I didn't want to take off so much material that I would start cutting through the bottom of the case because I still wanted to leave that intact. This took me a very long time. I know it seems like it's going by very fast, but this footage is actually sped up 60x. This easily took me a few hours because I had to check every time I would make another pass and then go and check again with the battery and making sure that it fit. And as you can see, I needed to cut off a lot more than I had originally thought. It was hard to get this extremely flat, so I had higher and lower spots, and that's why I marked that with the blue right there. I would like to let you guys know that this is not a tutorial, this is more of an experimental project. If you are coming here looking for a tutorial on how to convert a wired to wireless keyboard, I already have a very in-depth tutorial video on how to do that, and I will link it below. With that being said, if you are going to attempt this with a smaller 60% keyboard, then this video will be helpful to you. It was pretty dumb of me to start with modifying the case because I hadn't even proven to myself that I could pull off the wireless conversion, and you'll see why later I should have started with that first. This was actually a super loose paint job and I didn't really have a plan going into it, and I should have stopped right about here because I think it looks pretty cool like that, but I had the idea of wanting to put a stencil in the middle, and for doing that I needed a more solid color in the middle, but in doing that I kind of had to cover up what I already had painted, which I actually liked that more. But I kept rolling with it and I ended up adding some more layers and I thought it came out pretty good. This was more of just keep throwing down paint and then see what you got after that. I did put 2 layers on the stencil and I wish I had offset them a little more so I could have like a drop shadow effect. I'm not super thrilled with it, but it did come out pretty cool, and it is the bottom of the case so you're not really gonna see it that much anyway. I'm also not super partial to the color red, but I did have a lot left over from another project in which you'll see later. Again, this is just more experimentation, and I'll admit it didn't come out too terrible. And now we're getting on to the actual hard part of this build. I'm going to need some very small wires for this next part, so I'm just stripping a USB cable to scavenge the wires inside of it. I'm going to be attempting to solder these wires to the back side of a mini USB connector. I am by far not an expert at soldering, so this was definitely one of the more challenging solder jobs that I've tried. There are the 5 pins on the back of the connector, and that's what I'm going to be attempting to solder these wires to. This wire actually goes to the furthest pin from the rear, so I thought about trying to attack this from a different angle. This might actually end up being harder to do, but it will free up more space on the back and I have more wires to connect there. After trying to route it through the PCB for so long, I decided that it would be easier to try and attack it first to get it soldered and then try threading it through the PCB. And I'm soldering through the gap between the plate and the PCB. My soldering iron is so big that I can't even really see what I'm doing. I'm just kind of going off hopes and prayers here. I knew that I needed only one good touch from the soldering iron to get it to stay, and this was strike after strike of just trying to hit that home run. And I finally got it, and now that I did that, I have to try and thread it through the backside and down through the PCB. I have to do this because the connector sits flush with the case and the wire cannot come out that way at all. This was also a little nerve-wracking because I didn't want to keep tugging and pushing on that wire that I just got soldered because I didn't want to accidentally pull it out, so I'm just lightly threading it through. I I needed to pull it just enough for it to change directions. I was shocked myself because I had tried this so many times I felt like I had to give up. But I kept going and I actually got it through, and it's hard to see on camera, but right there is where that solder joint is. You can see how I snaked that wire around the switches, and these other wires were a walk in the park compared to the white one. And here it is wired up at least enough for testing. Now let's get on to the wireless components. This is the BT500 from Handheld Scientific, and it is my go-to wireless conversion Bluetooth module. Because this case is so small, I'm stripping down and removing any of the taller components that I don't need. So I did test it like this, and it actually worked to my surprise. There is still one glaring issue with this test wiring, and that is it does not account for being able to charge the battery. To charge the battery, we need to intercept the power and ground pins from the USB port. To illustrate that more clearly, I've made an infographic. In panel 1, you can see the original wiring of the backside of the mini connector. In panel 2, you can see where I need to make the cuts for the interception. And then you can see in panel 3 where I need to be soldering those wires. That's correct, I'm now going to try and cut the pins on the back of the connector, as if soldering one wire to the through-hole pins wasn't hard enough. I don't know why I'm trying and failing so hard with the X-Acto knife, but I move on to a better tool. All the tools I have are way too big for this operation here, but I still managed with what I had. I think I used the X-Acto because I wanted some precision in making these cuts centralized. And now that they're cut, you're seeing me bend them away from each other. All of these wires are converging in this one spot, and none of them can touch each other nor the outside of the connector. And here we go, wiring it all back up again with 2 extra wires. At this point, I had attached and reattached them so many times that I was getting better at it, but it still was far from easy. The mini connectors actually have 5 pins, but one of them is an ID pin, which isn't used. So that's 6 wires total, 4 power and 2 data. And now that that works, we can move on to more case mods. There's not a lot of room in this case, so I had to mount the power switch very low. Ideally, I would have mounted it in the back, but given the space, this is the most opportune place to put it. Now, since I had already worked my way all the way up to this point, I decided to make things even harder on myself. I decided to make this switchable between wired and wireless modes. To do that, I also need to intercept the USB data lines of the white and green wires. And you can see that a little clearer here in panel 4. This is actually the project where I learned that all keyboards do not act the same. On my previous V2 wireless conversion, you only needed to switch the white wire, but this Vortex board has firmware that will check to see if both pins are connected or not. So you can't get away with only switching one wire or the keyboard will not turn on. You actually need to switch both wires. I was doing some diagnostics because I was having some issues with the wires touching each other. This soldering job was not made any easier with this mammoth tip I was using. I should have bought a smaller tip for this job, but it's what I had, so I went with it. After a lot of adjusting the pins, I finally got all 7 wires to the back of this connector. They say 3's a crowd, but 7 is definitely a mosh pit. Definitely made more difficult with the fact that the tip is almost the size of the connector itself. And with the really hard stuff already out of the way, I went ahead and started wiring up the relays to aid in the switching from wired to wireless modes. Using these relays, it allows me to control everything off of one push button switch. Press it once to turn the keyboard on, and then you can double tap and toggle between wired and wireless mode. Let me show you the wiring diagram and where the relays are located in the circuit. When initially turned on, the white and green data lines are connected to the Bluetooth module. Double tapping the power button will swap these wires directly to the USB port. And now with everything all wired up, let's give it a test run. Here I am powering it on, and we're going to default to wireless mode. As you can see, the keyboard is wireless, and I'm pressing the Windows key, which is bringing up the start menu. And now I'm going to plug it into the wall so we can get some charging going on and still have the wireless connection active. You can see that it is still connected, and we also have the charge animation happening on the charge circuit. Now let's test the direct connection. Say you don't have a computer with a Bluetooth receiver, you can still connect it directly in, and it will also charge the battery at the same time. All of the modes work as intended, and also we have charging going on both wired and wirelessly. Now, I was thinking pretty smart, and I decided to add some connectors between these connections from the PCB and the case. This is going to make it a lot more convenient to work on in the future. And because this case is aluminum and conducts electricity, I'm insulating everything with some electrical tape. Now, the not so fun part of dismantling everything that you just made in the efforts to make all the wiring a lot cleaner. This is also a necessity because there are so many wires that it would be hard to stuff inside of the case without running into further problems. I almost always wire things this way, where I'll do one pass where all the wires are really long and messy, and then only after I have verified that the circuit works correctly will I start trimming down wires and making things a lot cleaner. I wanted to be extra careful with the wires that went to the back of the connector. I didn't want to pull them out or have them be bent or touching each other from the tension of pulling on them when I was stripping the wires. The last thing I wanted to do was try and resolder those again. I didn't want to make these wires too long or too short, because if they're too short then I would be tugging on them, and too long then I'd be having trouble stuffing them in the case. And after so much time of soldering everything up and getting it perfect, this happened to me. In all of my years of buying connectors from almost anywhere, I had never had this problem before. I bought a matching pair of connectors and they are not matching. I ordered these on eBay, and the seller was very nice and offered to remedy the problem with sending me the correct connectors, but that they didn't have any US stock left, so they had to get them shipped from China, which of course is going to take a lot longer. At this point, I didn't want to wait around anymore, so I decided to just directly solder the wires without any connectors, and maybe it'd be something that I got around to later, but hopefully the keyboard just works and I don't actually have to maintain it. That would be nice. Also, foreshadowing, because there are two parts to this project. My projects always seem to go much more smoothly in my mind. It wasn't until I started recording everything I was making that I can now see that I encountered quite a few problems with all of the projects that I've done. It's probably survivorship bias, where you look back at a project that you finally finished like very fondly. But if you go back and actually study everything that you did, you realize you encountered quite a few problems. Cleaning up the wires always seems to take about twice as long as just initially making the prototype. And even though this circuit is pretty simple, if you look at the wiring diagram, it's still fairly easy to get kind of twisted up and turned around in your head. So I'm kind of checking things as I go, as I make more and more connections, just making sure that at least that portion of the circuit works. It's easier to backtrack 5 steps instead of like 100 steps. This battery just barely fits in this case, even with all the hacking and modding that I've done to it. I also probably should have used some smaller power wires, because as you'll see in a little bit, having even this amount of wiring is still a ton to try and fit in this little case. And now that I have the battery finally hooked up, I can test the on-off switch and also the relays. These relays are so tiny that you actually have to feel them working instead of hear them working. And you can see I made a mistake and I put the white wires on the wrong pin, so I swapped them there on the relay. And that's why I keep testing things as I go. Okay, I am finally done with the wiring, and I definitely needed to add some hot glue to the back of that USB port, because I did not want those wires moving around and touching each other. That would be a massive headache just trying to figure out which wires were shorting on each other. I don't know why I wrapped the charge circuit completely in electrical tape, but I think I was a little paranoid that the pins from the PCB were actually going to touch the USB ports on it. I also was having a bit of a time trying to figure out where to fit these relays. The bottom of the case is pretty much off limits because of how the PCB slopes down at an angle, and I was still a bit worried that the PCB was going to be shorting on any of the exposed components. And here you can see I still have a spaghetti mess of wires under the case and just trying to fit them all in there. Those connectors would have helped clean things up quite a bit, but I think at this point I was just trying to get things to where there was a working concept going on where everything fit inside of the case. I must have forgot that I need 4 more holes in this case so I can see the charge circuit battery life indicator LEDs, and I was rushing a bit too quickly in this part, just trying to get these holes in there, and I didn't make them perfectly straight, which does bother me, but they are not too bad. They're only slightly off. I should have taken a bit more time and applied a punch for the holes beforehand. It's not too bad, but I definitely could have done a better job. I did attempt to clean them up a little bit more by elongating some of them, and it did help at least a little bit. Now you see why I should have done this in the first place, because I pretty much had to take out all the components that I had just tacked down. I think I had waited on this point and forgot about it because I wasn't exactly sure of the placement of all the components in the case. This was my first attempt, so it was an easy thing to overlook. Although it did give me the opportunity to find a new spot for the relays, which is going to allow for a larger gap between them and the PCB hovering above them. And after relocating those, I did decide that these wires were all way too long still, so I did another pass of refining the wiring. And because I knew I was finally getting closer to wrapping everything up inside of the case, I might as well take the extra time and make sure that it fits even better than it did before. I had thought that the tenkeyless wireless conversion that I did before was a challenge, but this was much more challenging. I honestly didn't even know if it was possible before I attempted it. Not like impossible totally, but impossible for me to do. I'm a firm believer that anything is possible given enough time, money, and resources. Now I'll just finish up doing all of the wiring refinement so we don't have a spaghetti mess of wires under the case, and also some insulating so we don't have any shorts when we put the PCB back into the case, and then a few test fits so that we can know that the PCB is sitting flush in the case. That was one of the issues with fitting this huge battery in there, is that it was bulging up, and that's why I had to take so much material out of the case. The PCB would just not sit flush down on it until I had carved out quite a bit of material. The wires kept wanting to lay over the hole for the dip switches, so some more strategic taping helped in that area. And I also didn't want this power switch to fall out, so I'm just reinforcing that with a little bit more hot glue. And after an arguably crazy amount of effort, we can finally put it back together. Just need the final keycaps back on, and then we can turn it on and check it out. I can't believe that it actually all works, and it works very well. The Vortex boards have these tracing LED modes, and I think it looks pretty cool. I call this the Michael Jackson Billie Jean mode. I know it seems like we are finished, but this is not its final form. I think this keyboard came out really cool and it actually works. And although I am quite pleased with how it has come out so far, there are still a ton of modifications I want to make to it, so stay tuned for part 2. I want to thank you guys so much for watching all the way to the end. I really appreciate it. Finishing up in part 2, we're adding a ton more mods to this already heavily modified 60% wireless conversion keyboard. Thank you guys so much for watching, and I will see you in the next one.